Hello, everyone. It is my pleasure to be here. This presentation on solar water pumping and sustainable development explores water, clean water, and energy access related challenges, examines a novel multidisciplinary approach to promote energy access and sustainable livelihoods, and it describes advances in solar water pumping for development. To start with, let's remember that water is at the core of sustainable development and is critical for socio-economic development, for energy and food production, healthy ecosystems, and for human survival. Water is at the heart of adaptation to climate change, serving as the crucial link between society and the environment. Energy, on the other hand, is the golden thread that connects economic growth, increased social equity, and an environment that allows the world to thrive. Research on solar water pumping for development often faces the challenge of choosing whether to focus on water, to focus on energy, or on poverty reduction. In my view, the three themes share the common preoccupation of people's unsatisfied needs. The question is thus how best to tackle energy and water poverty, which is particularly persistent in Africa. What do we mean by water and energy poverty? For example, 2 billion people worldwide are without safely managed water services, and 1 in 3 people have no access to safe drinking water. In respect to energy, 13% don't have access to electricity, and 75% of people without electricity live in Africa. Photovoltaics represent an appropriate renewable energy technology to address both energy and water deficiency. It is a technological solution. However, in our view, it is equally necessary that solar water pumping contributes to poverty reduction and sustainable development. Therefore, the question is how to warrant the modern solar water pumping technology will benefit those who most need it. How do we guarantee that it is affordable, remain operational for a long time, and avoid natural resources over exploitations? In principle, water access and energy access are multifaceted problems. To answer that question, we use systems thinking and also a multidisciplinary perspective. Such a multidisciplinary approach is SURE-DSS, which is a sustainable renewable rural energy decision support system which uses system thinking. It is a novel advanced modeling tool to assist decision makers to select energy solutions for improving livelihoods and protecting the environment. SURE employs an advanced multicriteria method and a package approach. It consists of 4 components: a modern energy technology, this is energy, specifically for energy, the multi-criteria method, the prospective uses, priorities and living conditions, and sustainable livelihoods framework. SURE-DSS is a package consists of software, surveys, guide to interviews, modeling system, and graphical and numerical outputs. It is the result of long-term project called Renewable. The sustainable livelihoods in particular is something I would like to concentrate on, and this these represent the resources owned by communities. The idea is that communities not only have needs, but also resources or capitals. These capitals are natural resources like land and water, physical resources like infrastructure or schools, financial resources, savings, social resources like networks or membership, and human resources, importantly, like skills, health, good health, ability to labor. The sustainable livelihoods may be represented in a pentagon. The system itself it has the following functions: builds a baseline of conditions and resources, assesses prospective users' priority through surveys, selects optimum energy technologies, determines global CO2 emissions of photovoltaic technology, calculates future impacts of energy solutions on livelihoods, and produces graphical representation of the outputs. It is a generic tool adaptable to any area, population, or nation, and finally, it addresses objectives generally present in policy programs. It is wonderful to see that these thinking and multi-criteria ideas on energy have grown and developed into new ideas to systematically integrate social, economic, and environmental factors in engineering studies of solar water pumping. Thanks to the creativity and hard work of excellent students and tireless dedicated supervisors, we have rolled out new projects in attempt to bring together all those components. On the back of the installation of a solar water pump in an off-grid rural poor village in Burkina Faso, successfully led by Simon Menier, we have designed new research questions and case studies, new modeling approaches and methods. For example, on optimization, life cycle cost and sensitivity analysis, machine learning, statistical correlations, and regression models. The themes that we have explored are size and geographical location of solar water pumping systems to maximize socio-economic impact and health. Another techno-economic study to determine appropriateness of hand or solar power pumping as per household water demand and cost. A technical study of water storage and battery storage using climatic data, aquifer features, water demand, and operation and maintenance networks. Another study looked into long-term water supply and payment scheme through forecasts of households' real water demand and willingness to pay. We undertook a quantification of solar water pumping impact on health, expenses, household wealth, and economic change. Finally, a study of solar water pumping system longevity and risk of water over extraction to ensure household sustainable water access. I'm sure you will hear more about these studies later on. To conclude, despite the improvements, energy and water access challenges continue and will continue for some time. Low carbon, renewable energy technology is necessary to address contemporary challenges. However, a technological fix alone is not sufficient. Social, human, financial, and environmental factors are required to be incorporated. New ideas will continue to emerge from the success and difficulties that we already experience in the projects, and we expect that new question and knowledge contributions will emerge. And finally, photovoltaic water pumping systems rollout in sub-Saharan Africa is necessary, and it will depends on proper engineering, investment, policy support, proper maintenance, and affordability to all. Thank you for your attention.